Hello everybody, today we will be going over a compound interest problem at the IB Math Studies level. So we have that Diogo deposited 8,000 Argentine pesos, ARS, in a bank account which pays a nominal annual interest rate of 15% compounded monthly. For part A, we need to find how much interest Diogo has earned after 2 years. So first things first, we need to find which information that is given to us here is useful, and to understand which of it is useful, we need to understand which formula we're going to be using. So the compound interest formula is right here, and as you can see, there's a couple things that are important. We have the variable fv, we have the variable pv, we have the variable r, we have the variable k, and we have the variable n. So essentially we understand each of these, what they do, and which ones we are missing. So as we can see here, FV is the future value, PV is the present value of your investment, N is the number of years, K is the number of compounding periods, and R is the percent of normal annual rate of interest. And so when they tell us that, for example, Diego deposited 8,000 Argentine pesos, this isn't how many Argentine pesos he ended up with, it's rather how much he deposited in the first place, so that would be my PV. PV is going to be 8,000 over here. Later on, they tell us that it pays a rate of 15% and it is compounded monthly. So my interest rate is going to be 15%, as I have it here. But since it is compounded monthly, my K, which is the number of compounding periods, will be 12, right? Because there are 12 months in a year. And lastly, for part A, they ask us how much interest Diego has earned after 2 years. We know that n has to be the amount of years, and so n is going to be 2. So conveniently, as we can see here, we only have one variable that we're missing, which is fv, and that would be the amount of interest that Diogo has earned. Now, to find the interest that Diogo has earned, I would have to have fv minus pv, right? Because that is like the amount of gain he has had, all right? So having that in mind, we're going to go ahead and plug into our calculator, and we end up with fv being equal to 8,000 times 1 plus r, and to put 15%, we're just going to put 15 on top. We end up with 100 times k, and we know that k is 12, close parentheses, exponent 12 times 2. So we plug this into our calculator, and we end up with the following. And so our future value is going to be 10,778.8084. This is the answer that we get if we plug everything into the calculator. Now, a common mistake that a lot of people do is that they say, hey, my answer for part A is this number here. However, it is asking for how much interest Diogo has earned. It's not how much Diogo ended up with. Okay, those are very different questions. Since we're talking about interest, interest is how much money Diogo has earned through his deposit. And so if he deposited 8,000 and he ended up with 10,778, we would have to do 10,778.8084 minus 8,000. Does this make sense? And this that I put here is the same as the FV minus PV that I put in the beginning, which is going to be our formula for interest. Okay? Or interest gains, better said. So if we plug this into our calculator, we end up with just about 2,778.8084. Don't forget your units, ARS. So this would be how much interest Diogo has earned after 2 years. So that would be for part A, the actual answer. Moving on to part B, they tell us that Carmen also deposited ARS in a bank account and that her account pays a nominal annual interest rate of 17% compounded yearly. After 3 years, the total amount in Carmen's account is 10,000 ARS, and to find the amount that Carmen deposited in the bank account in the first place. And so, keeping in mind how we set up the first part of the problem, right, because this would be for part A, for part B, we're going to approach it in a very similar manner. We're going to write down FV, PV, R, K, and N, fill in, and see what happens. So reading what they give us for part B, we can see that her account pays a nominal annual interest rate of 17%. So I'm going to go ahead and put R equals 17% right away. It is compounded yearly, and so K is simply going to be 1 because there is 1 year in 1 year, not like before that there was 12 months in 1 year. And that it is after 3 years, so N has to be 3, that her total amount in Carmen's account is 10,000 ARS. So we would have 10,000 here for FV. Now conveniently, much like before, we end up with only one variable, and all of these compound interest problems are always the same. You're always going to end up with one variable, and the hard part is getting the answer through the calculator, right? So of course part B is harder than part A. Why is part B harder than part A? Because if I plug this into our formula, we end up with the following. We end up with an FB of 10,000 equals PV, which is our variable, right? Times 1 plus R, which is 17%, divided by 100 times K, which is just going to be 1, to the power of 1 times 3, okay? And so getting rid of the times 1 real quick, because 100 times 1 is just going to be 100, and 3 times 1 is just going to be 3. We need to plug this into our calculator and get the answer. Trying to get PV alone, or essentially you can treat PV as a variable, so you can just plug in X here. And so in this part, of course, we want to get X alone. And so we need to see what is interacting with X right now. X is being multiplied by a number, which is the chunk or the parentheses that is right next to it. So let's find out what that number is. So we will go ahead, open up our calculator, and plug that in and see what it is. As we can see, that number is 1.6016, right? And so essentially we have 1.6016x being equal to 10,000. And so if we want to get x alone, which is my PV, we're going to divide both sides by 1.6016. So that's going to get rid of this number here. And we will end up with a value for x. So my value for x, after I plug everything into the calculator, is the following. And so we end up with 6,243.7055 ARS would be the amount that Carmen deposited in the first place. And so that is probably the best way to solve this problem. I think the most important part really is the setup in the beginning, these blue squares that I drew here, just leave really clear which variables you're looking for, which one you are missing, and after you find out which ones you're missing, it suddenly gets much more easier to interact with the problem because you just plug into the formula and let it flow, right? And so that being said, I hope it helped, and peace.